Today we're going to be talking about upper and lower bounds. So, what do I mean when I say this? So imagine we've got a rectangle. And to show you life isn't perfect, we've got an imperfect rectangle. And this rectangle is 15 centimetres long and 12 metres wide. And we know that the perimeter of this rectangle is going to be 15, add 12, add 15, add 12, which would be 54 centimetres. But as I've just said, life isn't perfect. Things are rarely exactly 15 centimetres or 12 centimetres or whatever length you may have measured it to be. There's always going to be inaccuracies in real life situations. So let's think about this length of 15 centimetres. And let's think about what we've already learned about rounding numbers. So if we were to round to the nearest centimetre, the smallest length that could be would have been 14.5. And we know if something is 14.5, we would round it up to 15. So it could be equal to 15. It could be equal to 14.5 and then be rounded up to 15. What's the maximum length it could have been? It could be anything less than 15.5 centimetres. But it can't be equal to 15.5 because if it had been equal to 15.5, it'd be rounded up to 16. So to have been rounded to 15, the maximum length has to be less than, that's why we've got the less than sign here, 15.5. But because it could be 14.5 and be rounded up, we've got less than and equals here. In the same way, let's think about the width, the 12 centimetres. What is the smallest width this rectangle could be? Well, it could be 11.5 because 11.5 is the smallest length that would be rounded up, and again it could be equal to 11.5. Similarly, the maximum length could be 12.5. Now if we use the minimum measurements, that would give us the lower bond. So we would add 14.5, add 11.5, add 14.5, add 11.5. And that gives us a lower bond of 52 centimetres. Similarly, for the upper bond, we take the maximum. So it would be 15.5 plus 12.5 plus 15.5 plus 12.5, and that gives us 56 centimetres for the upper bound. So this rectangle, the perimeter, can be anywhere between and equal to 52 centimetres and 56 centimetres. So it can be, the perimeter can be less than and equal to, can be greater than or equal to 52 centimetres or less than 56 centimetres. Now in an exam situation you may be asked for the least value of something and the greatest. value. And when you see a question where it says least value or greatest value, this is the kind of situation where what they're talking about, where you'll be looking for the lower bound and the upper bound. This is when it's in questions where you see least and greatest value, where you're going to be using this knowledge. So let's think of a kind of a question that you may be asked. So we're going to think of a girl called Anita. Anita is an athlete and she sprints along the track for 100 meters to the nearest meter. Her time is 12.5 seconds to the nearest half second. Let's write sec for second. So let's calculate her average speed, assuming that she ran exactly 100 meters and she'd done it in exactly 12.5 seconds. So average speed is distance over time. So the distance is 100 meters, the time is 12.5, so her speed would be 8 meters per second. However, as we said, in real life situations, it's rarely the case. What are the upper and lower bounds on her distance? So the distance, so 100 meters to the nearest meter could be 99.5 of a meter is the lower limit, and the upper limit 100.5 meters. So again, 99.5 would be rounded up, 100.5 would be rounded down, and for the time, so we've got 12.5. Now what did it say? The nearest half second. So the lowest limit would be 12.25 and the upper limit would be 12.75. So what would be her upper bound speed? Now for this, we're going to take the largest distance, so over her quickest possible time. Now if you think about that in real life situations, if she was to go the furthest possible distance in the quickest time, she would have to run at her highest speed, and that would give us 8.204 meters per second. And the lower bound speed, same logic, the distance would be the smallest distance she could possibly have ran, so the 99.5, but she'd have had to have done that in her longest time, so 12.75, and that gives us a lowest time of a slowest speed of 7.804 meters per second. So I hope that makes sense. Thank you for watching.